morning, everyone. My name is Aleksandra Tarkowska, and today we are going to dive into how real-time data integration can unlock the true potential of AI. A few words about myself. I am software engineer by profession, working in this field for like 20 years. In the past, I used to work as a developer as well, and now I work as an engineer. So let's move to the presentation. Over the next 20 minutes, I'm going to cover three key areas. First, I will explain the integration challenges, why connecting AI to real-time data sources has been such a difficult and complex process. Second, I will talk about Model Context Protocol, a solution to reduce this complexity that's transforming how we think about AI integration. And third, I will show you real-world use case, how this actually works in practice with concrete examples you can implement in your own project. By the end of this talk, you will understand not just what's possible, but exactly how to make it happen. Right, so let's start. I'm sure many of you used AI assistant for a simple task, maybe at home or at work, and ask questions about something happening right now. For example, about today's weather, like Mikey just asked, or a recent news, and only to hear that AI doesn't have access to that information. This happens because AI models are only as smart as the data they are aware of. And that's exactly the problem I'm going to talk about today. Let me show you what I mean. Here are real examples from different AI assistants. When they are asked what's the date today, for example, one model admitted that its knowledge is limited to 2 years ago. When asked about weather or lottery results from today, model suggested visiting the official website as knowledge was going only up to the beginning of this year. Let's stop and think about the implication. So consider, for example, a self-driving car that can't recognize traffic lights due to sensor delays, or a customer service chatbot without access to the latest inventory data. These aren't failures of the AI models. These are very sophisticated systems capable of remarkable reasoning, creativity, and problem solving. The issue is somewhere else. They are disconnected from the real-time data, from the real world. The AI is brilliant, but is operating in a vacuum. This brings us to the central question: how can we connect AI models to existing data infrastructure and systems in a way that's efficient, scalable, and future-proof? And how? It's called the Model Context Protocol, an open standard that was proposed by the Anthropic last year. So think of MCP as the USB hub for AI. Just like USB hub lets you connect multiple devices to your computer through a single standard interface, MCP creates a universal connection layer between AI applications and data sources. Before we get to the solution, let's dive into integration challenges. Imagine you have 3 AI applications, so chatbot, development environment, and AI-powered analytics tool. Now you wanted to connect each of those to 3 different data sources: your database, document repository, file system, or any other AI API service. So how many integrations do you really need? The maths is very simple. It's basically 9 custom integration. Each integration requires custom authentication logic, different data format and protocols, unique error handling, separate security implementation, and individual maintenance. Um, Now, when we look at this at scale, what if you have 10 AI applications and 20 data sources? That multiply to 200 custom integration. Not even ask how that go exponentially. Each one is a point of failure, of course. Each one needs to be built, tested, secured, and maintained. This is what it's called the M times N integration problem. Every time you add a new AI tool, you need to rebuild all these connections. Every time a data source change its API, you need to update every integration. There has to be really a better way to do it. And this is where MCP was introduced to solve this problem. Those same three AI applications and the same three data sources. Instead of 9 custom integrations, you just need 6 implementations. Here's how it works. On the AI side, you implement 3 MCP client, basically here, and they are lightweight components that speak the MCP protocol. On the data side, you implement 3 MCP servers to expose data sources, database APIs, documents, file systems. Now they can connect through a standardized interface here. So MCP provides standardized tools, predefined way for AI to request and receive data, resources, structured access to file databases and APIs, and prompt template for common interactions. So instead of exponential complexity, you get linear growth, and this is transformative. Let's stop and think about what this means practically when you deploy a new AI application. It instantly has access to all your existing MCP servers. When you add a new data sources, all your AI applications can immediately use it. No custom work is required. Now, you might be thinking that this sounds complex to implement. So let me show you how simple it actually is. Here is a complete MCP server built with a fast MCP in Python. This tiny piece of code creates a tool that only MCP client can use to fetch the current time. Let me walk you through this. We create an instance of fast MCP here, define a request model with a time format parameter, and create a tool with a simple decorator. The tool itself is just a function that returns the current time in the requested format. Run it on a port and you are done. That's it, over 10 lines of code. And you have created reusable service that only AI application can call through MCP. Want to add another tool? Just add another function. The simplicity is intentional. MCP removes the complexity so you can focus on functionality only. The best part of that is that you are not alone in this. MCP already has official SDKs for 10 programming languages: TypeScript, Python, Go, Kotlin, and others. Whether your team works in a modern web stack or maintains legacy enterprise system, you can implement MCP. The community is growing rapidly. Developers are building and sharing MCP servers for everything from databases and cloud services to specialized APIs and internal tools. Instead of building from scratch, you can often find an existing implementation to customize. Major AI platforms also are adopting MCP as a standard. That means the tool you build today will work with the AI systems of tomorrow. So let me show you what this looks in a practice. I have a custom application here is utilizing AI agents here there is a Llama environment running to create a report on population statistics with charts. It translates human languages to SQL query, execute the query against database, and return population data for visualization. So let me show you how it works. Yes, so here there is a server. Sorry. Again, here there's a server running. I have an application with a client integrated. Um, and now let's ask the database, ask model to give 10 countries by population in 2025, let's say as a pie chart. So it provided the data. The tool was called execute SQL query. The query was constructed with the join. Everything was done by LLM. And we can go through the thinking step of the model. Now let's get top 10 countries by population, but let's say in a different year, in 2023. And later we will do some maths to calculate the difference. Let's say now let's get this as a pie chart. Here we go. Again, the tool called created SQL query and called the database to get relevant data. So the data here is loaded to the context of the application. And now let's summarize as a text. And let's calculate if there are any differences between years. So let's see if LLM will be able to calculate the difference between 2025 and 2023 population, and if it suggests any correlation. So let's do some data analysis. And here we have it nicely calculated the data. As we can see here, it didn't call the tool anymore. It just used the data in its context and calculate the difference. So we can also go through the thinking process to see that actually data was fetched from the previous steps. And here is the difference between population over country, across countries. It didn't suggest any correlation, but it says that population changes are influenced by factors like economic growth, migration, demographic trends, and age community, and so on. So there is some pattern over time. So this is mainly it. I will be probably finishing earlier. Let me bring this all together. First, MCP server solves the M times N integration problem. Instead of building custom connections for every combination of AI and data sources, you implement standardized clients and servers. This alone can cut integration costs by 80% or more. Second, real-time data integration. Ensure AI models stay connected to the real world. No more, I don't have access to the information. It can actually fetch this information from the various sources we point them to. AI can answer questions using current data, whether that's live inventory, today's metrics, or the latest customer interactions. Third, MCP reduces development costs, improves scalability, and enhances security. You build less custom code, which means fewer bugs, easier maintenance, and faster time to value. The standardization also makes security reviews simpler and more reliable. Finally, the future of AI lies in a seamless universal communication between models and data sources. So MCP isn't just solving today's integration challenges, it's building the infrastructure for tomorrow. The gap between AI and the real world isn't a limitation of the technology, it's a limitation of how we have been connecting them. With MCP, we are building bridges instead of isolated tunnels. we are creating an ecosystem instead of a collection of point solutions. So thank you for listening.